right, so what I'm going to do is just show you a few slides just to put you in context of Nerves. So what is Nerve? It's a platform for customized software on embedded devices using a minimal built-root derived Linux that boots directly, and it boots directly the VM basically, so you don't have all the noise of Linux with libraries that you don't need on the device. Nerves is also a framework for all the libraries that we need to build and burn a firmware for such a device. And again, we have also the tools, all the command line tools for configuring, updating the firmware, and more. So in a nutshell, that's what Nerves is. It's a platform, a framework, and a set of tools. Some definitions, because we want to use those words for the next few minutes. So the host is the computer on which you are building your firmware, basically doing the coding and all that. The target is the computer that will run the firmware, so it's basically the device, the mobile device. The tool chain is the tools required to build the code. So that's something that is provided by Nerves, all the tool chain. And the system, it's the minimal Linux system that get into the firmware and then on the device. So they call that the system. And then a firmware bundle, it's a single file that contains the system, the application, the configuration, everything you need for the device is in a firmware bundle. And this firmware bundle is pretty small. I mean, it's really strictly the files that you need. And eventually you build a firmware image. This is a bit-for-bit image that is basically copied to the SD card that goes on the device. So we don't have to worry about all of that. Nerves is taking care of building that image from the firmware bundle. So Nerves provides a few packages for compiling and building the firmware. So we have Nerves, the Nerves system, whatever, and the Nerves toolchain, whatever. So those packages are strictly used to build the image. Nerves also provides packages for the runtime. So those packages will be on the device. So we have the Nerves runtime, Shoehorn, and Nerves network, a bunch of packages for networking. And we have a system registry, and I don't know exactly what they use this for. But as a quick note, because I think I don't have a slide for that, Shoehorn is the package that is between the Erlang beam and your application. Because you know that if your application crashes with applications you're building, it will kill the Erlang VM, and you don't want the Erlang VM to die on the device, especially when it's 2,000 kilometers away. And what is this problem here? Okay. All right, am I being hacked? All right, so Shoehorn makes sure that if your application crashes, it will restart it. So it keeps the beam happy, basically. So the beam always runs thanks to Shoehorn. Your application can crash, that's not a problem. All right, so this is the first demo. So what I'm gonna do is follow my little script here. And we're gonna go right here. So let's do some clear here. All right, so I'm not going, let's assume everything is installed. I have all the Nerves packages and dependency installed. So the only thing I need to do right now is to do a mix. It's probably not big enough, huh? All right, so to create a framework for an application, we just do mix nerves.new. Let's give it a name, foo. Init gadget, this is an option for the generator. Init gadget basically is a package that will include a bunch of networking libraries, the code for setting up the Wi-Fi, if you use Wi-Fi or the Ethernet port, whatever, or Ethernet through USB. So it's something handy when we build a simple application. for experimenting. But for a real product that you would do for an embedded device, you would probably not go within the gadget. You would probably have your own set of modules for managing the networking. So the target will be a Raspberry Pi Zero, and we'll set a cookie to secret. And that's all we have to do. So yeah, so that's what it's creating. It's pretty simple. Config, library, test, and that's about it. So we're going to install the dependencies. All right. So now, as any Elixir app, we just go into the folder. And now what we're going to do is we're going to compile the application for the Raspberry Pi Zero. So in Nerves, you need to set an environment variable. I'm going to clear that. So you see this. So I'm going to do export mix target, and my target is the Raspberry Pi Zero. All right. And then I can do another mix deps.get, because in the mix file, there are some dependencies that are based on the target. So I have all the dependencies installed, and then the only thing I need to do now is simply do a mix firmware. So that creates the firmware bundle. Of course, it compiles the code first. By the way, it's using Distillery to build the release for the software, so it's very familiar. Basically, any person doing Elixir would not be lost doing something for Nerves. All right, so the firmware is ready. Now we need to send the firmware to the device. So I mean, it's the first time we have a firmware for that device. So now I need to burn it, and actually. Not really burn it, but I need to physically transfer to the SD card. So we have a camera here. Let me stop this. All right, you can see this. Okay, cool. Yeah. So, is this the first time? Some people, have you ever seen a Raspberry Pi Zero, or it's familiar for everyone? Looks like it's not the first time people see this. So inside here, I'm going to unplug it. Yeah. So the SD card is pretty damn far away. So I need to take this out. All right, here it is. So I need to put that in my adapter here. Maybe the other way around. Okay. Now I just plug it here, and I need a USB adapter. So to burn the firmware, it's as simple as doing mix firmware.burn. And it detects a 16 gig memory card. Do I want to use it? Yes. I need to authorize the device. And that's it. So I mean, you can see it transferred 28 megabytes. That's it. 28 megabytes, you have Linux, the Beam. It's a very simple application, but that's pretty amazing, 28 megabytes. All right. It's already ejected, so I just need to remove it and go back to the broadcasting here. So this is a fancy adapter. I need to push this. All right. And then to put this in there. Okay. Now the tricky thing is to put back the Raspberry Pi and not lose the camera connection. All right. Okay, I think I'm good. All right. So I just need to connect this guy. And we hopefully can see some lights flashing. Do we see some? Yeah. See. So it's booting right now. It takes a few seconds. And by default, it's using the USB port to create a virtual network. So it's all configured to be available through nerves.local. So if I ping it, hopefully that will work. But I need to plug, oh no, it's already plugged. Yeah, we just need to wait a little bit. It takes what, 30 seconds to come up? Yeah, all right. Okay, so that's not very exciting, but at least it's on the network. So, I mean, when you deal with Raspberry Pis, when you see your Pi on the network, man, you get a beer, because it's especially with Wi-Fi, right? It's kind of a challenge. So, we can ping it, so that's SSH. And how come we can SSH the Pi? Well, this is part of Init Gadget. Init Gadget will install a SSH service on the Pi, so we can connect to it and debug. So I'm currently connected on the Pi, and there's a small hello function in the base module for the app. So if I do foo.hello, I get a response world. And the screen, maybe I should leave the full screen here. Let me, let's do this here. All right, is that better? Yeah. Pas tout à fait. Oh well, okay, so I'll take care of that. Okay. Yeah, so while I'm in here, I might as well show you that there is a logger, and they provide what they call a ring logger, and this is a way of caching the log messages on the Pi, and you can do a ring logger tail, and you get all the log messages on the Pi, which is quite handy for debugging. All right, so that was my first demo. Any question so far? No? Okay. Okay.
Can we try to crash the
Yep.
and see if you shell?
If you, what's your question?
Can we crash and see that it will start by sending green?
Oh, you want to see what is being sent to the Raspberry Pi?
Go home application that you said that
He wants you to crash your shell.
Oh, okay, yeah. Yeah, raise, boom. No, probably the shell is rescuing it. Anyone knows a way to list all the processes? Process that.
Oh, why don't you just do a self? You'll get the PID. You just kill the PID.
Yeah, right. So it's process.kill. No. Exit. And I can do, okay. I probably have help. Yeah, we do have help. All right, so process, exit, self, kill. And I'm back. I mean, it says, yeah, it's really easy to see here. Yeah, the shell process exited, and then I'm back in there.
Do it again, you get it. So we see the different PID.
Huh?
Do it again so we see the different PID. Yeah.
All right, yeah, good question. All right, okay, so I will leave this and go back to the presentation. Okay, so as Nicholas demoed, we have a checkout application. So the Raspberry Pi Zero will act as a barcode reader. It's using the PyCam package to get an image from the camera. We then use the ZBar package to detect barcodes in the image. Pretty simple to use. And then we send the barcode data to subscribers. which in this case is the checkout application. So, oh, I did have a shoehorn slide. So I mean, we built those presentations like in a nutshell on Monday, so it's supposed to be casual. All right, so shoehorn, it sits between the beam and your Elixir app. And this is how you configure it. So you just say, hey, just start and make sure those two packages are initialized. And that's basically it. So that is shielding the app, shielding the beam from the app that could potentially crash. Init Gadget, like I was saying, its main responsibility is to bring the network up and handle over-the-air firmware updates, which is pretty cool. When I played with Nerves like 2 years ago, that was not possible. Every time we had to burn physically the SD card. Now, as you will see in the next demo, we can upgrade the firmware through the air, through the network, which is pretty awesome. So Nerves in a gadget, it's just a matter of, well, this is a default configuration when you do a mix nerves.new. So you specify the interface name, the address method, the domain, the node name. So that's the Elixir, the beam node name scanner, and the SSH console port. Yeah, pretty simple. To send a new version of the firmware through SSH, we need to do some configuration. It's using SSH, so you need a key somewhere for encryption. So when you compile the app, it will take your public key that you specify in the configuration and embed it in the firmware. So that when you connect through SSH, it will only authorize connections coming from a known device. So this is pretty great. So the problem though is if I do something on my machine and then Nicholas tries to update the firmware, he won't be able to unless we include his public key in the configuration. All right, so demo number 2. No, right, it's here. Okay. So I'm gonna go in our bar project, and remember you saw this earlier, and we have 4 Poncho apps in there. So what we're going to do, we're going to focus on the scanner here, and I guess I need to resize my window here, people. All right, is this better? I'm going to do a mixed depth get, and as you can see, we use the PyCam and ZBar. That's all we need for the scanning. And then I'm going to do a mix compile just to make sure compile. Yeah, I didn't change any code, so that's all fine. I'm going to go back to the scanner firmware and do exactly the same thing here. Mixed depth get. And we have an error. Aha, yeah, I need to set my mix target. Now, we're using ZBar for scanning the images, and we need a library to be installed in Linux. So this is the more complicated things with Nerves. You need to use a special version of the Raspberry Pi, a baked-in a ZBar baked-in version of it. So there is one on the GitHub, and there's a bunch of systems that are available for Nerves, and there happens to be one called rpi_ZBar. So if I set the mix target there, I'm all good because my mix file expects to have the rpi0 target there. All right, that's it. So I just did the mix depth get. I need to do the compile. And I didn't have anything to change here. So I'm ready to create a firmware. And if all goes well, I'll be able to push the firmware to the Pi through SSH. So we do that by doing mix firmware.push and then the host name or the IP address, whatever. So nerves.local. It's probably a bit small. And yeah, that seems to be working. It's not as fast as burning it directly. It's going through a few stacks for the network. Okay, it's rebooting, so we'll give it a few seconds. And yeah, so let's go back to the presentation in the meantime. Oh, there's a question here. Yes, Mr. Henry.
What's partition B?
What's partition B? Ah, that's a good question. So earlier you probably saw partition A. So Nerves is setting up the firmware, well, the SD card is being formatted with a master boot record, a boot partition, and then 3 other partitions, 2 for the software, your application, partition A and partition B. They are read-only. So when you have your software on the SD card, nobody will be able to change it. And then you have an application partition, and this is available to you to use it. It's read-write, and you do whatever you want to do with that partition. But yeah, it's at your own risk.
But that allows you to, if the build doesn't succeed right,
yes,
go back to partition A.
Yeah, exactly. So if the question, well, the comment is, if you are having problems with the code that you released on partition B, either you were not able to upgrade the firmware or there's a major bug you find out, well, you can always roll back to the other partition and it will revert to the other partition and reboot the system. And actually we could do it from the SSH session if we wanted to. I'll just show you quickly here. There is a nerves.runtime and we have some functions in there. And there's one called revert, this guy here. So that will swap to the other firmware. And we can also reboot, we can power off. I mean, this is awesome. good call. All right, so I'm going to exit the SSH. All right. Okay. Now, we have the scanning and checkout application all deployed at the Pi. So now I can connect to the video streaming here. So let's do that. I need to be in Chrome. Whoa. So if I go in nerves.local video JPEG. All right, so that works. Now, what I'm going to do is I'm going to SSH again to the Pi. I'm going to clear that. And I'm in the console on the Pi. I'm going to subscribe the console to the scanner. So we have a subscribe function in scanner. So scanner, I have my barcode scanner module. And in there I have a subscribe function. And I'm just going to pass myself. All right. Now, if everything goes well, I can take a QR code and scan it. And that doesn't look good. All right, let's see if maybe I don't have enough light, huh? Flashlight to the rescue. Yeah, that doesn't look good. Oh. Who did that? Well, that's interesting. So what do we do when we have a bug? We have a logger. So let's have a quick look at the ring logger tail messages here. Yeah. Look this up.
Did you look at the mailbox? Flashing, something like that?
No, it did.
Oh, yeah, do you need to flush the mailbox?
Flash what?
Flush the mailbox and the other terminal.
There we go. Yeah. So for those who are not Elixir savvy, flush flushes the inbox, the inbox message. So if I scan again here, if I do a flush, yeah. All right, so that works. Finally, oof. Okay. All right, so now we're going to do it through distributed Elixir. So, if you remember, in the init gadget configuration, there was a node name scanner. So, by default, your Elixir application is running in a cluster mode on the Pi. So what I'm going to do, I'm going to start IEX, and I'm going to give my node a name. Let's call it foo. And I need to use the same cookie as the Raspberry Pi, and the cookie happens to be a very secret one. It's scanner. And all right, so this is running on my machine, it's not on the Pi. So let's get my PID. So my PID is 110. So I'm going to spawn a process on the Raspberry Pi by doing this. So I'm going to run on the node scanner on nerves.local. And I want to run a function in the scanner.barcode barcode scanner module. The function name is subscribe and my PID. And I have an error somewhere. Scanner barcode scanner subscribe PID. What is wrong? Oh, okay, yeah, because it's a list of arguments. All right, so my laptop IEX session is subscribed to the Pi. So technically, I should be able to scan again a barcode, flush the command, yeah, and I got it. So another clap. Yeah. So just to show you the power of the Beam Elixir, I mean, it's so easy to get things to talk to each other. And yeah, so it's easy because it's easy to test as well. You don't need a UI to test this. You can have testing, communication, and all those subscription pops up features. So I could walk you through the code probably, or it's probably too late, huh? Yeah, it's probably too late, yeah. So you can access our GitHub repo if you want to see all the codes there, but it's pretty simple. So I'm gonna, yeah, that's all I had to show you. Any questions on Nerves?